Hey, Sound Engraver here. Welcome back to the third installment of our pattern mini-series. Today we're going to look at three more subclasses under pattern, and those are going to be Pclump, Ppatlace, and Ppatlace. So let's go ahead and evaluate our bell synth def and get right into Pclump. So our definition is as read, a pattern that takes another pattern and groups its values into arrays. Now this is going to require two arguments. It's going to require an n argument, which can be an integer, or it can be a pattern, and it will return an integer. And the second argument is the pattern that is going to be filtered. So using this example here, this is actually found in the Pclump help file. I just shortened it just a little bit. Let's go ahead and take a look at what this Pclump has. We have our n argument being 2 and our pattern being pseq 1, 2, 3, and our repeats variable being just one time. So let's run this. And as you can see, it's evaluated as a routine. And x.next, or the next method, will run the following: 1 and 2, 3, and nil. So what does this mean? Well, our n argument is going to output 1 and 2, or the first two values, and the remaining is going to be 3. Now the reason why it's remaining is that this 1 multiplied by 3 values, being 3 in this case, 1, 2, 3, 3 values, 1 repeats variable. That's just how it goes, and so the 3 is just kind of wrapping it up there. So let's try 3, our repeats variable being 3, and our let's try our n argument just being 1. We've got 1, 2, 3, 1, 2, 3, and I can guess it's 1, 2, 3 one more time. Perfect. Before returning nil. So you can see 3 times 3 values being 9, and then returning as nil. So let's put this into a musical context. We're going to go ahead and do this with our rate argument, which of course changes the pitch. We have our n argument being 2, followed by a p sequence of 0, 2, 3, and 5, our MIDI values respectively, and a repeats variable being 4. So in this case, it's going to output 16 values total because of 4 values, and 4 being our repeats variable, and output 2 integers at a time. And I have the trace method there so you can see. So let's have a listen. All right, so it first outputted 0 and 2, and then 3 and 5, and then it did this for another 3 times, and you can see it is leading up to 1, 2, 3, 4, 5, 6, 7, 8, 16 times. Let's go ahead and do this one time, and well, let's go ahead and keep that there and change that. And we will go ahead and just do one integer or one note at a time at a random selection of repeats variable, either once or up to 4 times. So let's see what SuperCollider decides. All right, so 4 times, and let's just make it a little faster. All right, 2 times. Let's do 3 as our n argument. All right, just 1 time. And I believe that is if I can do my math correctly, okay, 2 times. All right, so that is our Pclump. So pretty interesting stuff there. Let's go ahead and expand this Pclump using a pseq as an argument. And so I have pseq being 1, 2, and 3 with the same MIDI value, MIDI note number there. And so the first instance is going to be 1 integer, then 2 integers. So in this case, 0 will be selected, then 2 and 3 will be selected because it's going to output 2 integers. And it should be 5, 0, 2 being outputted as our 3 integers being outputted. So let's have a listen. And there you go. So you can almost have this maybe ostinato for maybe some live performance, you know, something to experiment there. And why not add a pchef to the end argument? So it looks like it's going to output 2 and then 1 and then 3 before proceeding on to 1, 3, and so on. And something with something like pbind-def where you can re-evaluate it in real time to change that pchef arrangement to your fancy. All right, so I just extended it just a little bit more where it's a rather long P sequence. And yes, I have just 1 integer followed by 2 integers, 1, 3, 1, 1, 1. So kind of an asymmetrical feel. Let's start with a relatively fast tempo, arbitrarily. And I wonder if a fast, an 1/8 of a second for every note works. Kind of sounds like a minimalistic approach, if that's what you fancy. All right, Ppatlace. So let's take a look at this in the definition, and we'll kind of clear that there. All right, interlaced embedding of subarrays. So what does that mean? Well, we have an array here. Again, I got this example from this page here, Ppatlace. We have an array, and we have 2 arrays embedded, so by definition, subarrays. I think that's what it is. And so here it says it returns elements in the list. If an element is an array itself, it embeds the first element when it comes by the first time, and the second element when it comes by the second time, the nth when it comes to the nth time. So what does that mean? Well, I'll run it for you, and then we can talk about it. So what you have outputted in 12 iterations, as you can see here, we have 1, 2, 3, and then we have 1, 5, 6 before repeating again. 1, 2, 3, 1, 5, 6. So what that is saying is we have our first element here, and then we're going to proceed with the first element of the subarray before proceeding on to the first element of the next subarray before going back, cycling over to 1, second element, which is 5, second element of the second subarray, which is 6. That was a mouthful. So let's put this in context. So what you have here is our MIDI note, 0 being C, and it's going to output, it should output 0, 3, 7, then 0, 5, 9, and then 0, 10, because there's no third element in the first subarray. I think that's it. So let's go ahead and check that out. So let's double check that. We have 037. That looks good. 059. Great. Oh, okay. I was mistaken. It is 0310 before proceeding on. And then 057. Okay. And then 039. Okay. I was mistaken. And actually, I think that adds a little bit more variance and a little bit more, I want to say repetition, but it's not repetition, but I think the brain likes that kind of thing. Just a little bit of variance mixed with a little bit of repetition, and you are good to go. So Pplace is pretty cool in that respect. All right, Ppatlace, which I'm assuming is P pattern lace, but I could be wrong. All right, interlace streams. So similar to Pplace, but this the list is an array of streams or patterns, and the results of each stream will be, and here's the operative phrase, output in turn. And this is what makes it interesting and exciting. So let's go ahead and we'll clear that post window. Just a nice clean slate, see what we're doing here. All right, so inside this Ppatlace, we have a pseq and a pseries. And let's go ahead and check out what pseries is. An arithmetic series pattern. And you can see also that pgeom is a subclass similar to it. It has the following arguments, similar to pgeom, where we have a start value, but rather than a multiple factor or multiplication factor, we have an addition factor, and I guess they call it the step argument. And you have the length as your argument there, as I think it is with pgeom. So in this case, in this example, for our p-series, we have the first value being 1, and then adding 1 being 2, adding 1 being 3, and so on until value 32, going up step by step until value 32. In the context of Ppatlace, what we're doing is we're going in turn between the pseq and the p-series. So it'll first be 0, C, respectively. Oh, actually in this example, it's not going to be C. It's going to be 67, which is 7 semitones above 60, which is C. It's going to be G. So anyway, yes. In this case, in this example, which I got from the help file, we're going from 0 to this one to 0 to adding 1 value, the third 0 to the next value being 3, the next 0 being 4, and so on, all the way up until 32. And you may see, well, here's an if. Well, we'll see how that works. And I think I need to evaluate this synth-def here, so let me go ahead and do that real fast. You can see this in the help file here. All right, we should be good. So you noticed after that highest pitch, it goes back to our pseq. So after that 30-second instance, we're reverting to, actually that's not the correct word, we're going back to pseq and we're staying in this pseq for infinity. So there you go, there you go. Let's go ahead and put it into the context where we have our bell sound. And I'm going to add some rhythmic variety using our pseq here. And we have a Ppatlace, and I'm still using the p-series here. So in 24 instances, as you can see here, we're going to go back and forth from pseq, in this case it is C, 0 to 1 to 3 to 2 to 0 to 3 to 3 to 4, and so on. Let's have a listen here. I think that is pretty sweet. So that's quite fun. I really like this Ppatlace. But why stop there? Why stop at the rate? We can do this with all sorts of arguments. We can do something like pan if we used a UGen for stereo converting to mono, which I haven't done yet. Or we can use something like attack. So why don't we do just that? So same rhythmic variance. No variance. Actually, it's a PC here, so straightforward there. Same thing for our rate, as you had just heard. However, I added a Ppatlace for our attack. So our P-seek is full of very sharp attacks. You're going to hear every bell sound right at the start of that sound file. However, with Pgeom, now I'm using Pgeom, I start with a very soft attack. That is 1 second, and the bell sound is really 1 second, if not even shorter than 1 second. Actually, I think it's a little bit longer now that I think about it. But the point is, it's going to be a very soft attack. And then using Pgeom and this multiple of 8, we're going to decrease the number. And so the smaller the number gets, the sharper the attack becomes. And like before, we're going to have 24 iterations of that as our repeats variable. Yes, I think that's it. All right, let's go ahead and have a listen. So you can barely hear it at the start, and then it kind of creeps up into a sharper attack. So I think that's quite flexible. And I did include trace here, where you could see at that last instance, that 24, we have, a fifth, 5 milliseconds essentially, so right at the start. Whereas before, our first instance is right at 1, you can barely hear it. And really, it's not until that, let's see, 1, 2, 3, 4. It's really the 4th instance where you start adding that multiple, and gradually that sound becomes more perceptible because the attack is it's much closer to 0. Let's have a listen one more time. So pretty flexible there. I like that. I'm really going to use Ppatlace, if that's how you pronounce it. That's how I'm going to pronounce it. That's how I'm going to use it. I'm going to explore it and have fun with that. So hopefully this demo has given you some inspiration how you can apply these pattern subclasses to SuperCollider or in SuperCollider to your music for your music composition purposes. Yes, that was Pclump, Ppatlace, and Ppatlace. So yes, thank you for watching and listening. Hope you had fun with that demo. I had fun with this particular one. I really like these subclasses. So always be on the lookout for sound experimentation every Thursday. And again, thank you for watching and listening. I will see you next time with some more patterns. Thanks again.